going to solve uh, this CSES 2 sets problem. I think this is a very easy one. This is part of introductory problem in CSES. So let me, just 1 second, let me write it over here. So it's an introductory problem that we are going to solve. I feel like this is a very easy problem. Here the problem says that we need to divide the numbers up from 1 to n into 2 sets, two equal sets, okay, where the sum of the numbers in each set has to be equal. And if it's not possible to divide the numbers into 2 sets, then we need to print no as our answer. If it is possible to divide, then print yes, and if it is possible, then we also need to print the numbers within the each set and the size of the set. So here, as you can see, n is 7, so it contains the number from 1 to 7, right? So let me write it here. So it contains number 1, 2, 3, 4, 7, and we need to divide it into two equal sets. So first of all, we can verify that how if it is possible to divide into two sets or not. How can we do that? If the sum of the whole thing, right, if the sum of the whole thing is even, we need to verify if it is even. It means it can be divided into two sets. So here, as we can see, the sum from 1 to 7 is 7 times 8 by 2, which comes out as 28, right? Sum equals to 28, which means that each set should have numbers which sum to 14, right? So each set should have 14 each, right? So here, as you can see, first set over here contains 1, 2, 4 and 7, and which sum up to 14, right? 7 plus 4 11 plus 2 13 plus 1 14, and the number of elements in this set is 4, so that's why the first that size needs to be printed. And then again, size of the other set is very easy. Whatever is it's not part of the first set is it will be part of the second set, right? Because ultimately it is going to be sum to be 14 itself, right? Because the total sum is 28, and if we are able to find the first set, then we have eventually have found out the other set as well, right? So we can print that as well, and the size of the second set. So this is if we talk about the solution for this, it's very easy. We basically have to iterate from the end, so which is from 7 and till towards 1, right, in the descending order, and we keep checking if the current element is less than or equals to the sum that we are trying to find out. If it is, then we keep adding as part of the first set, right? And we also keep decreasing the sum that we are trying to find out, right? So for example, let me, so yeah, so initially the sum that we are going to find out is 14, and something that will be part of the first set is nothing initially, right? And then when we start with I as 0 1 2 3 4 5 6. Yeah, so we'll be starting with 6, right? Yeah. So if we are starting with 6, index 6, then we can see that 7 is definitely less than 14. So yeah, we make it part of our first set. Let me also add it set 2 over here, and we increment the ith counter, and we decrement the sum that we are trying to find out. So now we only need to find out 7, because 7 we have already found, right? So increment the decrement the I to 5, and then we check for the element 6. So 6 is also less than equals to 7 that we are trying to find out, right? So we also make it part of our first set. Okay, then we decrement I again. Okay, yeah, so we make it 4, and we also have to decrement the sum that we are trying to find out, which will becomes 1, because 6 we have found out of 7, right? So 1 is remaining. Now if you check at index 4, uh, it is 5, and 5 is definitely greater than 1, so it doesn't basically satisfy the sum that we are trying to find out. So we make it part of our another set, right? So now at this point, set 2 has 5 as well. Okay, and set 1 has nothing. So now we decrement I again. So now let's make it 3. So at 3 we can see it is 4, which is still greater than 1, right? So we'll not include in the first set, but we can include in the second set. So 4 is there. Now we again go to 2, and 2 is also greater than 1, so we make it part of our second set. Oh wait, it's 3, right? Yeah, my bad. So at index 2 it is 3, and which is also greater than 1, so we skip that. Now next comes is 2. 2 is also greater than 1, so we'll not include in first set, so it will be part of second set. And we will decrement this again, so it becomes at index 1. 1 was 2, so yeah, now it comes to 0. So at 0 we see that yeah, it is less than or equals to sum, right? Because it is equals, so we can definitely include it in our first set, and then done. There is nothing left to process further, because I has come to 0 and we have already processed all the elements. So if we see that yeah, the first set also has 3 elements, and the sum is actually 14, and the set 2 has a sum as 14 as well, right? 5 plus 4, 9 plus 3 plus 2 equals 14. So we have found one set. It We know that it doesn't match with the answer that we have in example, but that's okay. It doesn't matter, because what we care is any elements which satisfy the condition of equal distribution of between two sets, right? So that is all. And if we talk about the solution that we have for this, let me grab my code. So only the implementation part has few caveats while implementing, because in Java it was throwing time limit exceeded if we print out all these elements in each of the set separately. And so what I did was I used a string builder for that. So here as you can see, I'm checking, if I'm first of all I'm collecting the sum, and then the half sum each set must have, right? So I'm collecting the sum by 2, and then for each of the two sets I'm taking the string builder approach, where I'm for each of the element from n to 1, I'm checking if it is greater than half sum, that the sum that we are trying to find out is greater than equals to the current element, right? If it is so, then we will decrement it, we'll make it part of the first set, we'll append that into the string builder, and then we add it in a space. Otherwise we make it part of the second set, and that's it. If, and also we make a check over here that if the sum is not divisible, it means that it cannot be distributed equally in two sets, then we return no. Or another case is like, if even if it is divisible in two equal sets, because it is even number, it is possible that the sum that we are trying to find out is eventually uh, doesn't meet the condition, that it will not have the it will basically not have the sum, a half sum, right? In that case as well, it will answer will be no. And other than that, if it's not, if it says yes, we are able to divide it, then we print it yes, and the size of the first set, and then the remaining size of the second set, and the second set itself, right? Because both are the string builder, so we can print it as it is. So yeah, that was it. Hope it is clear. Thank you.